Hi class! Welcome to our math class. I'm Teacher Kim, and for today's topic, we're going to talk about shapes. So you already had this on your elementary years. However, today, we're going to find out how can we use quadrangles in the modern geometry. So stay tuned, and before that, do not forget to subscribe to my channel and click on the notification box. Thank you. So our topic is quadrangle. So what is the basic definition of a quadrangle? It is a four-sided plane figure. So we have example here. It can be a square, it can be a rectangle, or a polygon like here. And in any given quadrangle, the perimeter does not change. It is constant. And for any given parallelogram, opposite sides remain parallel. What is a complete quadrangle? So a complete quadrangle is a system of geometric objects consisting of any 4 points in a plane. This is a plane, we have 4 points. So 1, 2, 3, 4. Correct. Wherein there are no 3 of which on a common line. So mostly we have here in a one line, you can only see here 2 points. Another one line, 2 points, another one line. So you cannot see 3 points in a line. It is always, or there are no 3 points on a common line. And the 6 lines connecting 6 pairs of points. So these 6 lines are connected in pairs. This complete quadrangle was called a tetrasigma by Lachlan 1893. It has 4 points that no 3 of which are collinear. So that. How about complete quadrilateral? What's the difference, ma'am? So the complete quadrilateral is a set of 4 lines. We have 1, 2, 3, 4. No 3 of which are concurrent. So as we can see, based on our figure, lines are connected by pairs. So we cannot see 3 lines in a point. It is always 2 lines at each point. 2 lines at each point. And the 6 points incident with each pair of these lines. So it is connected to the second statement. So points, each 6 points are connected by pairs of lines. 1 point, there are 2 lines. Second point, there are 2 lines. So the 4 lines are called sides. And the 6 points are called vertices of the quadrilateral. So these are 1, 2, 3, 4, 5, 6. So this picture is the representation of a complete quadrilateral, which is called a tetragram, wherein there are 4 lines that no 3 of which are concurrent. Pair of lines in a point. Pair of lines in a point. So in conclusion, the 6 lines of a complete quadrangle meet in pairs to form 3 additional points called the diagonal points of the quadrangle. So go back. There are the points are connected by a pair of lines. So from that, we have another line that is diagonal to this pair of lines that is now consist of 3 lines in a point. And that is called a diagonal points. there is an additional point or line, there is an additional point that was connected by that pair of lines. Similarly, among the 6 points of complete quadrilateral, there are 3 pairs of points that are not already connected by lines. So what are these points? It is located in the middle, these 3 points. Why? Because it does not complete a one line. The first 2 points is another line, and this another point in the middle, and this point is another line. So they intersect only at that point. However, it is not a line. It is a 2 line, not a 1 line. So the line segments connecting these pairs are called diagonals. So these are the first line segment, second line segment. They are called diagonals. Points and lines in a Euclidean plane, the diagonal points cannot lie on a single line. So that was based on the Euclidean plane. And also, diagonals cannot have a single point of triple crossing. Like this one, single point of triple crossing. Based on the Euclidean plane, it does not exist. However, due to the discovery of the Fano plane, which is a finite geometry in which the diagonal points of a complete quadrangle are collinear. So, the complete quadrangle and complete quadrilateral both form projective configurations. So, what are these configurations? So, the notation of projective configuration in tetrasigma is written as 4 sub 3. So, this is a sub 3 ha guys. 4 sub 3, 6 sub 2. And the tetragram is written 6 by 2 and 4 by 3, where the numbers in this notation refer to the numbers of points, lines per point, or lines and points per line of the configuration. So we have here tetrasigma. So go back. We have 4 sub 3, 6 sub 2. So this one, 4 sub 3, 6 sub 2. So there are 4 points and there are 3 lines in a point. The sequence is points, lines in a point, and then we have the lines and points in a line. Then the 6 sub 2 is there are 6 lines and there are 2 points in a line. So that is the 4 sub 3, 6 sub 2. In tetragram, the second figure, we have 6 sub 2 and 4 sub 3. 6 sub 2. Same pattern. So we have points, lines in point, lines, points in line. There are 6 points, and then 2 lines in a point, and there are 4 lines. Each of that line has 3 points. So line 1, we have point 1, point 2, point 3, 3 points. Line 2, there are 3 points, and in here also, and in here. So that are the notation or the projective configurations of the two figure. So in here, it is the combined figure of the quadrangle with quadrangle and complete quadrilateral. So in here, the KLMN is a complete quadrangle. This KLMN. And D here is a projective harmonic conjugate of C with respect to A and B. That's for the projective properties of the complete quadrangle and complete quadrilateral. So, thank you for listening, class. See you on our start next